All right, so for the last page, so you have two numbers here that you need to find GCF, greatest common factor. So the first thing we need to do is find the prime factorization of 60 and 126. Okay, so we do it this way. First, I'm gonna make, basically we will make a factor tree. So we need to think of two numbers that will factor out to 60. So you have 6 times 10. It doesn't really matter. You have many numbers, but whatever comes to mind as long as they're equal to 60. And then you have to ask yourself, are there any more factors of 6 other than 1? If there are, then you have to continue. So that 6 will be 2 times 3. And then 10, same thing. Do you guys have any other factors for 10? Yes, you do. You have 5 times 2. Now we have 4 numbers. Now you have to keep on asking, do you have any other factors of 2 other than 1 in itself? No more, right? So the only factors of 2 are 1 and 2. So therefore, since you got to the end of the line, you have your final factor is 1 and 2. You can just circle that. Same thing with 3. Let me see a minute. So sure if I have, okay. Same thing with 3, since there are no more, 3 is a prime number, and the last factors of 3 are 3 and 1, so that's also the end of the line. Same thing with 5, no more factors other than 1 in itself. Same thing with 2. So now you're going to copy that here. You write 2 times 3 times 5 times 2. So these numbers are your prime factors of 60. And we will do the same thing with 126. Okay, any two factors, you can, if it's too big a number, you can just divide it with any number and see what works. Okay, like if you divide 126 by 2, you'll end up having 2 times 63. Okay, now 2 of course is prime number, just like if it's 2, 3, 5, they are already prime, so you don't have to worry about them, just circle them. Now, but 63, however, you still have factors of 63. So the factors of 63 are 7 times 9. Now, ask yourself again, is 7 a prime number or not? Well, it is, because the only factors of 7 are 7 and 1. So therefore, that's the end of that line. However, for 9, you still have 3 times 3. And then of course 3 is a prime number. So now we will copy all these numbers that we circled for 26. So you have 2 times 7 times 3 times 3. So make sure you count them correctly. You have 4 circles here, then therefore you have 4 numbers. And so now to get to find the GCF, the word here is GCF, greatest common. So it has a common factor for both numbers. So what we're going to do is we're going to look for a number that is on your 60 and also on your 126. Okay, I'm going to circle that. The 2 are common to both of them. 3, you'll have a 3 in here, so that's also common. All right. 5, there's no 5 here. 2, there's no more 2. So therefore, your only common factors are 2 and 3. So therefore, your GCF will be the product of those two numbers. So you have 2 times 3. So this 2 is from this first 2, and that 3 is from that. So you just multiply them back, and so that's 6. So therefore, your GCF for 60 and 126 is 6. Okay? So I'm going to do number 2, and I'm going to leave you do number 3. All right, so we do the same thing. I'm going to write the 45 right here, and I'm going to write 225 right here. Okay, and we need to find your GCF. So let's start with 45. So you kind of need to make your factor tree. 2 factors of 45, that would be 9 times 5. 9 is not prime, but 5 is, so I'm going to circle that. Now factors of 9, if it's not prime, therefore it has other factors. That would be 3 times 3. Both these 3's are prime numbers. So therefore, for 45, you have 3 times 3 times 5. So that's 3 times 3 times 5. That's equal to 45. We do the same thing with 225. Well, it ends in 5. So if that's too big a number for you, you can divide them with 5 and find out. Okay, but for me, I'm going to try 9 times 25. That's equal to 225. 9 is not prime, so I still need to factor that into 3 times 3. But 3 is a prime number, so I'm going to circle that. 25, the factors of 25 are 5 times 5, and these are also prime. So I'm just going to copy that here. 3 times 3 times 5 times 5. Now to find your GCF, common factors, we need to do the common numbers that's on top, on the first number and also on the second one. So you have 3 here. You also have another common 3, so you have 2 3s common, and then you have 1 5 common. So therefore your GCF is 3 times 3 times 5. So you basically just multiply each one, and that will be equal to 45. So that's the GCF for 45 and 225. That means 45 can be divided by 5, by 45, and 225 can also be divided by 45. Okay, so you do number 3. I'm gonna move on to the next part. Okay, I'm gonna use this space right here. So this is the same context. Find the GCF. So I'm gonna just copy this one right here. 14x to the 5th, y to the 4th, and you have 7xy cubed. So first things first, I need you to do the 14 and the 7, factor 3. So factors of 14 and 14 are 2 times 7. Both of these are prime numbers, so that's the end of it. And then for 7, it's really just 7 times 1, right? So if it's 7 times 1, you just keep the 7. So for the 14 part, you will write 2 times 7. That's the 14 part. Now for the x, you have 5 x's, so you have to copy x times x times x times x times x. So x to the 5th means you multiply x 5 times by itself. 1, 2, 3, 4, 5. And then for the y, 4 times 1, 2, 3, 4. So these are the prime factors of 14, x to the 5th, y to the 4th. We do the same thing with this. So you have 7. There are no factors of 7 other than 7 and 1. You have 1x, and then you have 3 y's. Okay. All right, so for the GCF, whatever is common on both, you will circle. So now you have common 7, that's 1. You have 1x, okay. You have 3 y's, so this y right here, this y, and then this y right there, the second set, and then this y right there. So therefore your GCF would be 7 for this 7 times x times 3 y's, 1, 2, 3. So when you simplify this GCF, that will be 7x y to the 3rd because there are 3 y's. Okay, so I'd like you to do number 5, factor out the 4, factor out the 18, and then write a here 3 times, b 2 times. Just circle the ones that are common. Okay, so now let's try the last part. Okay, so for this one, the assumption here is you need to find the GCF for both terms. Okay, so but really the idea here is as find the GCF and then factor the expression. So if you want to do the find the GCF for this one, really the easy part here is you just look at the numbers first, the coefficients, and what's the biggest number that can divide 2 and 4, and that would be 2, right? And then look at your variables, the b to the 4th and b to the 2nd. The GCF will be the one with the lowest exponent. So between 4 and 2, it'll be 2. So this one becomes b to the 2nd. So this is your GCF. Okay, that's the GCF. All right, so let me try that again. So to find the GCF for this, for the number part, for the coefficient part, find the biggest number that can divide both of them. So 2 and 4, the biggest number is 2. For the variable, is the one with the smallest exponent. So between 4 and 2, that's going to be b to the 2nd. This is the GCF. Now, so that's one of the factors. And so now to complete the answer, what we're going to do is we will divide this by that, by the GCF. So Let me just clean this one up first. All right, so the GCF here, I'm just gonna write the GCF because you have two things that you need to do. For the GCF is 2b to the second. So that's the GCF. Now for the factors, we will write it here. In the factoring, you need to write the GCF first. 2b second, okay? Now 2 divided by 2, that's 1. B to the fourth divided by b squared, that's b squared. And then there's a minus sign. 4 divided by this 2, that's going to be 2. B squared divided by b squared, that's just 1. So this is it. So these are your factors. Okay. All right, let's try number 7. The GCF again for this one. Look at the letters, the numbers 6 and 9. The biggest number that can divide both of them is 3. You have letters x. So you have x cubed and x to the second. The smallest exponent is 2. So that will be x squared. Now you don't have y here, you have y here. So therefore the smallest is if you don't have y. So therefore this is your GCF for number 7. So for the factoring, we need to write the GCF first, gx squared, meaning the GCF is one of the factors. All right, so now we will divide one by one. 6 divided by 3, that's 2. X cubed divided by x squared, that's x, because you need to subtract the exponent, 3 minus 1. And that's it, minus. Now this time 9 divided by 3, that's 3. X squared divided by x squared, that's 1. You don't have to write. And then you have an extra y, so you just write y. There's nothing to divide it with but 1. This is the GCF. This is a factor. All right, number 8. You do 9 and 10, and I'll do 8. All right, so GCF for number 8. Okay, you have 2 letters. You compare first, J. This is J to the second. This is J to the 1. So therefore, the smallest exponent is 1, so that's just J. For the K, K squared and K to the 1, so therefore that's just K. So this is your GCF, JK. All right, so in the factoring part, I'm gonna write JK first. And then we will divide this by the JK. All right, J squared divided by J, that's just J. Remember, this is J to the 1, so you subtract the exponent. Same thing with K squared divided by K, you have K. All right, minus JK divided by JK. Remember the property, when you divide it by itself, it becomes 1. All right, so this is the complete factor. These are the complete factors. So why don't you try number 9? Oh, you have 3 here, so think about, okay, numbers first. What's the biggest number that can divide 12? 6 and 3. And then for the M, like look for the biggest, the smallest exponent, M cube, M square, and M. Which one has the smallest exponent? For the N, well, you don't have N on this third one, so you do not have N as a GCF. For P, everything has P, so they all are P to the 1, so that's also your smallest one. So that's your clue for the GCF. All right, so that should cover that. If you have questions, just let me know. Just do the last 2, okay?